Good morning, and this is Mr. C, and you've tuned into your next math lesson. Thank you for watching. Once you have your name and your date and our new lesson title underlined, which is 2-7, using expressions to describe patterns, you may unpause the video and move on. Alright, now you are checking your homework, which we should have gone around and seen if you have it done. By the way, this is the last lesson until our test. We will just have a review after this and then the test, so we're almost done with chapter 2, so we're trying our hardest today. Once you're done checking your homework and filling in the correct answers, if you got it incorrect, please move on. I do want you to pay careful attention and just notice how in the homework answers, just as I noted in the last lesson and talked to many of you, that when you substitute a number, such as x equals 9, into a problem, that we always put it in parentheses to tell me that I'm multiplying. So that's in parentheses. I also see over here that they put that into parentheses, d equals 4, and it's 3 times 4. They put that into parentheses. I also noticed that for the one over here, 2 times g, they put that in parentheses right here, 2 times 6, and g is 6. All right, I'm ready to go on. All right, so today we are using expressions to describe patterns. The question is, how can you write expressions to describe patterns? So let's read this first word problem. Delvin saves a part of everything he earns. The table at the right shows Delvin's savings pattern. The input column shows the money he has earned. This is the money he has earned. The output column shows the money he has saved. Output is the money he's saved. Write an expression to describe the pattern. All right, and as you can see, I like to label my columns based on information from the problem. So I know that input is earned. Input column shows the money he's earned, and output is saved. So I put saved right here. So I'm looking for any type of pattern from how much he earned to how much he saved. So to find a pattern, I'm going to look from this number to this number, 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 and so on. And I'm thinking, what happens from this number to this number? And you might notice, but there must be a rule that applies every single time, and the rule doesn't change. All right, well, this is the vocab that will be in the next slide. But an input-output table, such as right here, is a table, which is a box with specific separations, of related values. Identify the pattern. What is the relationship between the values? So I see 84 right here. Half of 84 equals 42. Half of 84 equals 42. You may have noticed this. Also, let's see if it applies down here. Half of 66 is 33. 33 is half of 66. I noticed that that's the same pattern there. I'm saying, does that apply here? Well, 50 is half of 25. Yes, it is. Okay, so we noticed a pattern from here to here. And I see that we are writing an expression. We want to write an expression. That means that there's no equal sign. And I'm going to label this X. And so the pattern that we noticed is half X. Half of whatever we have in X equals my output. So we would just use substitution here. So half of 84 here, and then when I multiply that, because it's right next to each other for parentheses, I would get my output. So for example, I could put half, and then I could put 66 in here, and I'd get my answer of 33. The other way that you could write that is x divided by 2, because that's the same as if you took half and multiplied it by x. And we're going to get more practice on noticing patterns later on in today's lesson. I'm seeing that the table here is up and down, but we always go from input to output when we look for a... All right, so I see vocab notes, and you could have received this as a picture to tape or paste into your notes if you started right away. If you did, congratulations. If not, please begin writing this and making this table for your vocab notes. You should also draw a nice little picture to represent what's happening. Pause the video, and we're going on in 3, 2, 1. All right, so we're on to example 1. We know that This means Mr. C is going to do this. You're going to copy it in your notes, and then example 2, you're going to try to do before I give you the answer. So let's read this problem here. Use the input-output table for 1 and 2. Our problem here, 1 and 2. Here's our input-output table, and we know the pattern is always going to go from input to output. And let's just go back to the other table. This table is side to side, but that still means we're going from input to output. It doesn't matter if it's up and down or side to side like this. All right, so we're asking ourselves, what happens from the input number to the output number? Just look at these for a second and see if you notice a pattern. From 2 to 5, what's happening? From 3 to 6, what's happening? From 4 to 7, what's happening? So here the question is, if the input number is 8, what is the output number? Well, I see the input numbers only go up to 4. So let's just try a strategy of elongating our table. This is a good strategy. You'll get it. You'll get the answer. So I'm noticing that these go in increments of 1, 0, 1, 2, 3, 4, 5. And notice I'm trying to get up to 8. 6, 7, 8. Now I want to notice what happens from these. 3, 4, 5, 6, 7. All right, those are going up by 1 as well. All right. So now I have an input of 8, and I want to know, and they want to know what is the output number. Well, I elongated the table. That's a strategy we can take, and I have an 8 for an input, and so now I know that 11 is my output. All right, but now we need to write an algebraic expression that describes the output pattern. And if you're wondering, what should I have written for example 1, you should have this table, you should have this question and the answer, and you should also have this question written. Okay, so now we need to write an algebraic expression. Remember, the expression does not have an equal sign. And we said, I wonder if you remember what letter we had assigned to input, because we're always going to assign that letter to input. We assigned X to input. Okay, so something X. What is happening from this to this? All right, I notice that I'm adding 3 here. And I want to know if that also applies here. So you notice how we're going from input to output. Plus 3. 1 plus 3 is 4. That is correct. Let's see if it's right here. 2 plus 3 is 5. We're right. So we found the rule. We found the pattern. So we could write X plus 3. And that's what happens. You could put any number in for the input. And if you add 3, you would get your output. Pause the video if you need to. We're going to go on. 3, 2, 1. So here's example 2. And you're going to try to do this by yourself and then unpause the video to see the answer. Please go on in 3, 2, 1. All right, so you may have noticed this table from before when we did the teacher example, before example 1 and before the vocab notes. This is the same table right here. So we have this copied in our notes with these values, and we want to know if Delvin earned 36 mowing lawns, what input-output entries would you add to this table? So we know that he earned 36. I added that to the table because they want us to add it to the table, and we want to know what would the output be. Well, I'm noticing for this one, I would need to know the pattern from input to output because we go from input to output every time. I would need to know the pattern from here to here in order to then substitute 36 in there. And I remember example 1, they told me that half of X was the expression for this problem. So for example, you can take any X, see this is in the X column, any X, put it in here, and you'll get your output. So half of 84, and you're going to get 42. So now we're going to substitute. That's why we learned substitution already. See, we're in the X column. We're going to substitute this next number, this new number we got, of him earning 36, and we're going to substitute it in for X. So we get half of 36, and I'm wondering, what do I get? Because we need to know this right here. And if this is harder for you to do, what you would do is do half times 36. And when you multiply a fraction by a whole number, 1 actually goes under the whole number. You'd multiply across. You get 36 divided by 2. That would be our answer. I would then need to divide 36 by 2. My preference, instead of multiplying something by half, just do a quicker way, and I know that 36 divided by 2, I'll get my answer right here, because I noticed that this is divided by 2 to get to 15. So 36 divided by 2 is what? Well, if you divide this out, you know you get 18. If you divide 36 by 2, you'd put 18, and then you have your answer. He should add these two to his table. But what algebraic expression using division also describes the output pattern for the table above? Well, I actually went through this already in the first problem. Half of x, that's the same as x divided by 2, or you could write that as x divided by 2. Take any number x, divide it by 2, and you will get this number. Pause the video if you need to, and we're going on in 3, 2, 1. All right, so for number 6 through 9, you can work on it with a partner or by yourself. Please pause the video, and answers are coming in 3, 2, 1. Thank you very much for watching this video. After you're done checking your answers, please go to the gas station on Socrative, and then you may go to Khan Academy. And if you didn't know, you are awesome.